Hello. All right. Hello, everyone. My name is Connor Chevli. I am a staff software engineer. I am the technical lead on the core.app, core web team.
Hey everyone, I'm Gergley Lovas. I'm an engineering manager at I Avalanche working on core mobile and the extension.
So we're going to talk to you all today a little bit about how to build a multi-chain dApp. And what the future holds for dApps. So basically, I know a lot of you guys probably already know, but what's a dApp really quick? It's a decentralized application. It's a web app that interfaces with a decentralized network. It's how users interact with Web3 today. So what I mean by multi-chain is there's a couple different ways that you can think about it. You could approach multi-chain from the perspective of several blockchains, but all within a single virtual machine, a VM. And the VM is actually what drives what APIs are available for that chain. And this is also what drives what indexers are able to index, like Glacier, and what just basically, the interface for working with that blockchain. But then you also have multiple virtual machines, which is a totally different idea. And this is really the direction that we're heading, because everything right now is an EVM. You could work with Polygon, Avalanche Seed Chain, Ethereum, and you could build an app that's built around this EVM concept and have all the support for several VMs. But this isn't actually going to be scalable for the future. There's going to be more than just the EVM, and we need to start building around that. That's what the whole Subnet platform is all about, too. So this is really why we should be supporting multi-chain dApps too. Because, right now there's a few issues with the way that dApps are kind of spread throughout our ecosystem. The fragmented UX is probably the first issue. You have several, say I want to get USDC on some esoteric blockchain. Maybe the way that I get that is I go to a centralized exchange, I purchase it there, then I have to transfer it to my wallet, then I have to bridge it maybe to the blockchain that I actually want to get it on, and in that process you're interacting with maybe 5 different applications, and that's difficult. That's not a great user experience. So this fragmented UX is problematic. It makes it difficult for new users to onboard, and it also has its own security implications too. If I'm interfacing with 5 different applications just to accomplish a single task with Web3, that means I have 5 times the security attack vector surface area. There's a lot of different places along that chain that could go wrong. So if you want to build a multi-chain dApp, then all of a sudden you can start to consolidate interfacing across these several blockchains into a single place that users can trust, which is a little bit better. And then the other thing is scalability. The whole, I think that we can all agree that multi-chain is the future. There's a lot of benefits to it. A single blockchain doesn't have the modularity. We need that modularity to be able to support a bunch of different use cases for blockchain. We need the scalability behind it. Several blockchains, if you can have several processing transactions, that's going to be how we can achieve a higher transaction speed. So if we're going to have these multiple blockchains to achieve that scalability, we really should be planning our applications around that concept as well. So there's a few examples. You have OpenSea, DBank, Alchemy. These are a few different applications that you can work with that are already working with multi-chain. They're pretty much, for the most part, one virtual machine that they work with right now. So Core is trying to expand that. We, right off the bat, have EVM support. We have C-Chain, that's Ethereum as well, along with all of our EVM subnets. We also are starting off with Bitcoin support, which is pretty big. That's one of the very few places that you can actually interact with your Bitcoin. And then we also are going to be giving first-class support to subnets, which is our scalable solution. There's going to be several new virtual machines that are going to be built upon subnets in the future. So having a place that we can support those is going to be really important. So that's one of the core concepts of what Core is all about.
So you decided to build a multi-chain application. You will face some challenges. Some of them are inherently coming from the fact that we only had Ethereum originally. So wallet providers are built to interface with a single chain at a time. You are either connected to mainnet or testnet or some other chain. And that is defined in EIPs. The users will face constant chain change prompts, and they are all EVM focused. So some networks, for example, don't even have a chain ID like Bitcoin, but the wallet provider enforces you to come up with a fake chain ID, for example. The data is another issue. The chain information, as I mentioned, usually is EVM specific. It has, like, for example, the chain ID, which does not necessarily is present on some of the chains. You have X amount of chains, you will need X amount of RPC connections to get the data. And that means many, many RPC requests unless you are using some sort of indexer. And not all data is available on RPC. Like, how do you know where the tokens are? What kind of tokens the user has unless you know the exact token addresses you want to fetch the data for. And tooling is the third big issue. The tooling is built around the providers, the single chain, and mostly around EVM. So they are really geared towards that. If you want to interface with multiple different chains or cross-chain transactions, you will run into issues that are not really documented, and they are lacking examples.
So Gergley and I are front-end developers, meaning there's really two halves of everything that we build. There's the whole design, UI, UX side, and then there's also the whole engineering side of it. So we're going to talk a little bit about how you can handle multiple virtual machines from a front-end perspective a little. So on the design side, really it boils down to one simple core concept, and that's just to simplify as much as you can. If I have Bitcoin and I have AVAX, those are actually, under the hood, vastly different data structures for what constitutes a balance between those two. But users do not care. Users don't care that Bitcoin is a bunch of UTXOs and when you send a transaction, you're sending these UTXOs, which are like dollar bills, the equivalent of crypto. But users don't care about that stuff. But they do care how much Bitcoin they have. They do care what their US dollar value is. So the idea is taking these unused, technically vastly different concepts from multiple blockchains and distilling that down to a simple concept for users to understand. So you could take Ether, AVAX, Bitcoin, and all of your ERC20 token balances, and you can consolidate into what's my US dollar value balance. Here are all the tokens I hold. This is their distribution. Just simplify it. And that's really what it comes down to, just hiding these technicalities of these differences in the underlying data and just focusing on what users care about. From a development perspective, there's really two core concepts that we approach when we're handling the development side of multiple VMs, and that's one, modularity. You need to build. We approach it with a service-based architecture. So basically, isolate parts of your code base that are dedicated to dealing with each of those virtual machines, but then you can kind of have these higher order. Actually, yeah. So for those low-level data layer ones, you might have API that interfaces with the EVM RPC. You might have a service that interfaces directly with a Glacier indexer, or Bitcoin for block cipher service. But then so these raw low-level data layers. But then you can have these higher order data layers as well. I could have a balances service that takes these different virtual machines and distills it down into what the users care about. And there's really two different approaches that you can take when it comes to handling that data, and it's normalization or type guarding. So basically, that's the difference between taking Bitcoin data and or one virtual machine data and another virtual machine data, and trying to normalize that data into a data structure that's consistent between the two. There's some pros and cons. Like pros meaning you kind of have to do that to get a total US dollar value out of the two. But the con is that you can actually lose a lot of the underlying data, which could be really important in the UIs that you're building. So that's when you want to type guard. So basically, for that, for example, say you have a table in your UI that's showcasing a list of your activity, your transaction history. Some of those transactions might be BTC transactions. Some of those might be EVM transactions. But basically, you just keep the underlying data structure, kind of a sushi belt, a blend of maybe one EVM, Bitcoin transaction, some other VM, and then more EVMs transactions. And then you just say, if it's an EVM transaction, display your activity row for EVM. if it's a Bitcoin transaction, display the Bitcoin activity row, which maybe has a drop-down that can show you all the UTXOs if it's an Explorer and you want to display that level of detail. Things like that, because preserving that underlying data structure is really important. There are differences that do need to be displayed to users at times.
So you have your services. Each of them is connected to some sort of data source. But what kind of data source should it be? You pretty much have two options. Either pull the data from RPC or use an indexed API like Ava API. Both of them has some advantages and disadvantages. One of the biggest disadvantage of RPC is that it's super low level, and you have to make, as I mentioned, many RPC calls. But it's decentralized. And users can use their own RPC if they want to. With indexed APIs, they provide you a lot nicer pre-processed data. You can have all the balances the user has on a given network. It is way more fast, and but it's centralized. And there are some security properties that you have to pay attention for. So for example, what happens if two addresses are swapped and you are sending btc.b instead of link.e, which has a lot higher value, that can be really problematic. This is just something that to keep an eye on. So you have your UI. It shows beautiful data, but you want your users to be able to transact, and you want the transactions to be smooth as possible. So this is how we do it regularly nowadays. First, you connect to the wallet, then request the connection with the ETH request account RPC request. Then you switch to the chain you want to transact on. This is critical. You have to do this. Then create the contract with the address and the amount and everything, and then just call send transaction. And it magically sends the transaction, waits for the confirmation, and all is done. It's easy, but it has some UX issues. So in this example, you see that the user is prompted to switch chains whenever they change the network on the UI, and you don't necessarily know which button on the UI will trigger an extra pop-up to the user. This can really throw your users off, and they might even abort the whole process and not even do the transaction at the end. So what we are proposing and what Core is currently supporting is a way to do cross-chain transactions. With a slightly change, the user flow can be a lot smoother. First, you need to create a wallet provider, just like before, but instead of using the wallet provider to construct the transaction, you also use a chain provider for the specific chain you would want to transact on. Then connect to the wallet and construct the contract with the chain provider instead of the wallet provider. This will give you a transaction request, and that transaction request can be sent to the wallet. Now, I mentioned before that the tooling is really geared towards a single chain. So now the send transaction function does not work anymore because it is connected to the wallet provider and is waiting for the transaction to be confirmed on the network that the wallet is connected to. So instead of that, we have to send the transaction directly through RPC with the ETH send transaction call, and that will issue the transaction on the chain we want it to. So how does it look like in practice? With the slight change, the UX is a lot smoother. I can just switch chains on the UI, and then when I decided, okay, I want to send the jewels on Avalanche mainnet, I can just do it, and I will only be prompted once to confirm the transaction. So as you can see here, on the confirmation pop-up, there is an indication that, hey, it's not the chain the wallet is connected to, but the transaction pop-up looks the same. So the user is able to confirm that it is, in fact, on the chain they want to transact on and can issue the transaction super easily and in a way smoother experience.
Well, hold on. I think that, Gergley just showcased a really awesome example of where we're at right now, right? Making it really easy to work with multiple blockchains, but you're still working with one blockchain at a time, right? You still have to select that you're on DFK, Subnet, or C chain, or whatever, or Bitcoin. I think that there's a future where you don't even have to care what blockchain you're on. And I think that that's actually the direction that multi-chain dApps are probably going to head. So say I have one USDC on AVAX C chain, one USDC on Dexalot Subnet, but I actually want to do an interaction that requires two USDC on DFK Subnet. Now, right now, you would have to still go through that process, send that USDC from chain to chain until it ends up at DFK, and then you can do your transaction. But that's, I think that's too much. Right now, that's what we have to do. But imagine that you could just go to DFK Subnet, send that transaction, and then have under the hood, have it resolve what blockchain your tokens are on, because USDC is an equivalent on these multiple chains. So really, they're one-to-one relationships. So why can't we just automatically pull that one USDC from C chain, that one from Dexalot, and then just pull those into DFK, and then handle that transaction under the hood right away? I think that's really the direction that we're going to head, and it's empowered by some really new developments that we're coming out with. I don't know if you guys saw Michael Kaplan's talk yesterday on Teleporter. That's, basically that protocol allows us to transfer any ERC20 on a subnet to any other subnet. So all of a sudden, this might even be possible right now. We also have really powerful bridges. I know there's been some layer 0 talks, some other options too. I think that dApps need to start handling all of these different mechanisms for transferring tokens between chains and consolidating them so that users don't even need to worry about it and they can focus on the action that they're actually trying to perform. So I think that's the future, and that's about it for us.
Thank you.
Yeah, we could open up to some questions.
First of all, great presentation. Thank you for that. I have a question. You mentioned teleporters, but from my understanding, teleporters only work on the same virtual machine, or could they work on different virtual machines?
So yeah, Teleporter is only for EVMs right now. And that's really what Teleporter is. But the underlying protocol behind Teleporter is warp messaging. Mm-hmm. This is a VM agnostic protocol. So right now, Teleporter is totally built for EVMs, but doesn't have to necessarily be that way, because the messaging protocol that's powering it is actually enabled on every single subnet, regardless of your virtual machine. So yeah, right now for sure, but maybe not in the future.
Awesome. Thank you. Is it in the roadmap as a possibility to add the gasless feature in the wallet, so that the user will be able to make transaction by owning likely only USDC and no AVAX completely?
So in core and in mainnet, it's probably not part of what we want to do, but on the subnet scale, there are talks about supporting gasless subnets, and there are discussions how to create a way so someone else pays for your gas, for example, or really how to support gasless subnets. But on mainnet, probably we will not.
Full disclosure, I'm on the web team as well, so friendly fire. I'm just curious if you could tell them about types and how typing has helped simplify our web app a lot in what you mentioned with the grouping of different pieces of the code base, because I think it's a mega benefit that all these guys could probably take into account.
Totally. How many of you guys are actually, JavaScript or some strictly typed language developer? All right, a couple. Very cool. So really, when I mentioned the whole normalization versus type guarding thing, the whole concept behind that is, you could have this sushi belt of data, and then within your strictly typed language, you could actually develop methods that allow you to further scope down the data type. So say you maybe have a data type that's, EVM transaction or BVM transaction types. You could have, just pass that data through a function and have it handle it and spit out some response that allows you to say that this is actually an EVM transaction, and therefore we can display or process that data in the way that works for an EVM, and you can do the same for Bitcoin or any other virtual machine. So really this is just more of an underlying pattern that we have been following in our apps, and it makes it so that we can actually preserve the underlying data structure, so you don't actually have to try to shove the whole Bitcoin UTXO model into an account-based model. You could actually preserve that structure and therefore use it in places in your UI or in your code that you need it when you need it. So yeah, preservation of that underlying data structure is really important for sure, and type guards are pretty much the only way to do that. All right, thank you everyone.